This video is going to have a look at non-right triangles and how we can find a side or an angle in one of them using the sine rule. So far what we know about triangles is if we've got a right angled triangle, we can pretty much find any side or angle using our trig ratios and Pythagoras. However, what happens if we're dealing with a situation like we've got below? We've got triangle ABC, and I'm just going to highlight in green what we know. So we know angle A and we know angle C. We know all three sides, and I've just labelled them as we would normally label a triangle because the side opposite the angle has the same notation, just a small letter, a lowercase letter. So angle A, the side opposite is little a. So what we know here is that we've got two angles and we know all three sides. So imagine if I said to you, I want you to find the length of side X. Well, the only thing we can do essentially is have a look at the two right triangles that are made here. So we know length. Let's have a look at this first triangle on the left. We can call it triangle 1. So essentially in this triangle, we know the angle. So if we look from the angle, we want to find the opposite side and we know the hypotenuse. It just so happens we're defining the sine rule, so we're going to use the sine. So the sine of angle A is equal to the opposite side X over C. So essentially, side X is just equal to side C times the sine of angle A. And we know side C and angle A. What we could also do, though, is find the length X by looking from angle C, because we also know angle C, and we could be using the second triangle, the right triangle on the right. And if we do that, we look from angle C, we could say the sine of angle C is again the opposite side, which is X, over the adjacent side, which is A, which we know. So we could define X as being side A times the sine of angle C. And if we knew what those values were, we could just pop it in our calculator and voila. But what we actually can identify here is we've got two expressions that represent the length X. So really what we're saying here is that C times the sine of A should give us the same value as A times the sine of C. Now, if we rearrange this to put all the parts involving a C together, I'm going to undo this times by sine C by dividing on the other side. So I'm going to have side C over sine C of angle C, and I'm going to undo this times sine of angle A and divide it on the other side. And you can see why I'm doing that. I want to have my related side and angles together. And what we've actually found is the definition of the sine rule, which says the ratio between a side and the sine of its angle will be the same for every pair of sides and angles in our triangle, which means that we can even extend this to say that side B over the sine of that angle B opposite side B will be equal to side A over the sine of its opposite angle A and equal to the ratio of side C over the sine of its angle C. It's a really beautiful relationship that we've got between sides and their opposite angles, and that's what I call essentially a pair, because these are the relationships that we have in a non-right triangle. So this is really lovely because what it allows us to do is if we have got 3 bits of information, it helps us find a fourth. And we're going to see this in action in a moment. So let's have a look at our first example here. In our first example, we've got triangle AB and C. We know that angle A is 112, angle C is 24, and side little a, or the length BC, is 12 centimetres. And we want to find this side that has a label of C, our unknown. So in examining this triangle, I'm trying to think, what do I know? Well, I know a beautiful pair, a relationship, that side A, which has a length of 12, and we've got its angle 112. What I've also identified is I've got an incomplete pair. I know that angle C is 24 and I want to find the length of its opposite side. So that tells me straight away that I can use the sine rule. I'm going to find a length, so I can say, okay, well, length C would be over the sine of angle C, and that should be equal to the length of A over the sine of angle A. So if we pop this into, substitute in what we know, we don't know side C, and I know that the sine of the angle opposite that side is 24, and side A is worth 12 centimeters over the sine of 112 degrees. So all I want to do is rearrange this. Now sine of 24 is just a number, so to undo this number I'm going to multiply. So 12 times the sine of 24 over the sine of 112. Now we don't actually work out what the sine of 24 is, we leave that so we don't lose our accuracy. And when we pop this into our calculator to one decimal place, we get the length of side C as 5.3 centimeters. Now looking back at that triangle, that does make sense because angle C is very small. So side C should be quite small in comparison to angle A, which is an obtuse angle, so it should be much larger than side C. So what do we do in the case of our second example? We've got triangle ABC. We want to find angle C this time. We know side C, we know side A, and we know angle A. So again, we can use the sine rule, and that's because I have got a complete pair, the ratio of a side to an angle, and then I've got my incomplete pair here. So let's go ahead and use this sine rule. The one thing I am going to do just to make my solving a little easier is I'm going to just flip my whole sine rule upside down. So because I want to find an angle, I'm going to write that at the top. So it doesn't matter which way I write my ratio. The sine of angle A over side A should be the same as the ratio of the sine of angle C over side C, because I want to find angle C. So let's fill this in. I'm going to put sine C over here. So sine C over the side 45 should be equal to the sine of 56 degrees over side A, which is 60. It's not a very nice 60. So the sine of angle C, well, I'm going to get rid of this divide 45 by multiplying on the other side. And again, I'm not going to work out what 45 times sine 56 over 60 is. So now I want to find just angle C on its own. Just going to move this up here. Angle C. Well, to undo the sine, I need to do the inverse sine of that whole bracket, and I would just put that in my calculator and then inverse sine my answer. And I should get my angle C, I'm going to put my little angle sign in here, should be 38.4 degrees to one decimal place. Now if we have a look, that should make sense because the 56 degree angle that we've got for angle A should be opposite a slightly larger side because angle C is only 38, which should be opposite a smaller side. So that certainly makes sense. So this is the sine rule, looking at the ratio of the side and angle relationships that we have in any triangle. So now it's your turn. Got some questions here. The first two are straight skills questions, determining the value of x and theta, the angle. And the second one just brings in the use of bearings. So I'd like you to draw a picture for question 2. Once you've formed your triangular picture, you can use the information to find the distance of the ship from B. Have a go at that now and pause the video. And once you've answered these 3 questions, come back to the video and press play and the solutions will be there. You can check your answers and bring your work to class for our following lesson. Here are the solutions to your questions.